All right, starting unit 7, 7.1.1. What we're going to try to do is keep the videos relatively short, and there'll be a few more of them. Trying to keep them under 5 minutes, and just be prepared for that. So, essential question: how are the pre-image and image similar in dilations? I want you to notice that we're using the word dilations quite a bit here. How are pre-image and image different in dilations? When are dilations used in the real world? So, first off, what are dilations? Okay. Center dilation, the point through which dilation takes place, blah, 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 all this stuff. Here's the key word right here, dilation. Okay, there's all these words are important, but dilation is what this whole lesson is going to revolve around. A transformation in which a figure is either enlarged or reduced by a scale factor in relation to a center point. So in other words, think about when you take a picture on Microsoft Word or something like that, and you click that bottom right corner and you drag it just to make it bigger, right? Everything stays the same. The proportions are all the same. It's just a picture either gets larger or smaller depending on what your drag and drop does. Okay, so that's the idea here. All right. Then we have scale factor. I will go back. Sorry. If you scroll down, there are a few more definitions here. You need to make sure you know these definitions. So pause them, write them down. Make sure you get those. All right, so if you go back, this is going to go back several units. Unit 5, we talked about rigid motion, translations, rotations, reflections. The 3 of those are all what you would call rigid motions. Okay, they maintain the shape and size of what you started with. Now, non-rigid motions are transformations that are done that changes the figure's shape and or size. Now, what we're going to talk about today, dilations, will not change the shape. It'll still look exactly like it did before, but it will change the size. So that's why it's considered an example of a non-rigid motion. Okay, so key concepts. Dilations require a center and a scale factor. Scale factor is how much bigger or smaller. It'll be some factor, some number. If it's between 0 and 1, you're getting smaller. Think about multiplying by a number between 0 and 1. If I multiply something by 1/2, it gets smaller. If I multiply something by 1 1/2, or 2 or 3 or something bigger than 1, it'll get larger. Okay. The center of dilation is the point at which all the points are stretched or compressed around. We'll look at examples of that in a minute. The scale factor of a figure is a multiple of the lengths of the sides from one figure to the transformed figure. This last one down here is really important. Use a ratio of corresponding sides to find scale factor. The length of the image divided by the length of the pre-image equals your scale factor. In other words, if the length of your pre-image is, say, 1, and the length of your image is 4, then that means your scale factor was 4. You multiply by 4 in order to get your new number there. Okay? All right. So here's an example of that. So here's the length of the original, right? And we're going to do a scale factor as under dilation of scale factor K through the center. So if you look, you think about this as being, I know it's not exactly 1 because we did the distance formula. It's actually square root of 2, which is irrelevant, but you get the idea here. So if that's 1, and that's another 1, and that's another 1, then our scale factor is 3, right? We had to multiply this times 3 to get to the furthest end. Okay? In other words, it takes 3 of these, right? 3 of those little segments to make the whole. All right? That would be called a stretch. It got bigger. Okay? If it's bigger than 1, like the example of there, it's called an enlargement or a stretch. If it's between 0 and 1, it's a reduction or a compression. Those are 2 words that go with that. And if it's the same, if the scale factor is 1, that means nothing actually will change. It's the exact same shape in the exact same size in the exact same place. And then that's called a congruency transformation. And that's it. The scale factor is exactly 1. You won't see too many of that, but it is worth knowing what it is. Okay. It's kind of like that identity transformation. You multiply something by 1 or add 0 to something, it stays what it already is. Okay? All right, so a couple of things here, more notes. Make sure you write this down and keep thought of them. The notation here is important. The dilation on k of xy means you multiply the x value by k and the y value by k. You know that notation is important because we did it with rotation, deflection, and transformation. Basically, if you're doing a scale factor of 2, you multiply the x value and the y value by 2 for each point in the shape. Okay? The center of dilation is usually the origin unless otherwise specified. So we'll focus mainly on the origin for what we're doing. All right, I'm going to stop that video there. Well, let's show you this real quick. So here's an example of dilating around this center point, and then we're dilating V, U, and T. So these points are the original pre-image, okay? And so we go from T to T prime. So up one, right one. So we go up one, right one, up one, right one. Our scale factor is 3 here, okay? So I need to triple what I'm doing. So up 1, 2, 3 over 1. So I need to actually go up 9 over 3. So I triple both of those. And the same thing here. I'm at right 1, 2, 3, 4, 5, up 1, so you go over 15, and then up 3. All right? That's the idea. So you got to do it at all points. Common mistakes, take a look at those, or properties, and then common errors and misconceptions. Pause and read those, and then we're going to start on example 1.